This work is really kind of funny because it came out of a conversation with Connor. I don't know where you are right now. Hello. That was initially aiming at something sort of very ambitious, and it was basically about, can we run Zeek, formerly known as Bro. This talk is completely Zeekified. I will try not to use the word Bro, but I don't know if I will succeed. And Suricata as one system, which, if you've sort of looked at this for a while, is like, no matter how you go about it, like, really ambitious. And so we went over this a bunch with the Suricata folks, the Bro side, and at some point we asked the question, so like, what at the end of the day does really matter for this? And it basically came down to just having good ways to link your data together, to be able to pivot from one log type to another, from one system's logs to another system's logs, and so forth. And so we sort of noticed that there isn't really a particularly well agreed upon standard for doing this, and this is what this talk is about. And in a way, it is in part so basic that I'm almost embarrassed to talk about it, but I guess we have to start somewhere. So we call this the community ID, and I guess you can sort of guess where this is going. So the problem to start with is, here's a typical snippet from a Suricata EVE log, and you see that it has nice highlighting of flow IDs in there. So you can, for example, correlate the alert event here on the left with the HTTP event on the right. So that's cool. And so like in Suricata land, you're set. This is great. If you do this with Zeek logs, it basically looks exactly the same. So on the left is a snippet from a conn log in JSON form, and on the right-hand side is a snippet from an HTTP log in JSON form, and you see that you can link together your flow IDs because the system also produces these. Now, when you have, that's great, when you also have a combination of these logs, like on the left here, a snippet from a Bro log, and on the right-hand side, a snippet from a Suricata log, then it's not so great. So you have the details of the flow tuple in there, but the details matter. So you don't really know automatically which fields to look at. Things might be spelled out differently. Here it's TCP, there it's TCP uppercase. There might be a protocol number if you go from the protocol level number, and so forth. So this is really not so great. Like, you can still link that together, but it'll be substantial manual effort. And so this is not great, but I'm here to tell you that we can do this better, and as I threatened, this is the community ID. We came up with this name basically because the two communities were doing something together, and this is something that happens really rarely, which is also why I'm so pleased about this. And after a bunch of back and forth, what we came up with is really pretty basic. This is it. So I've come here to tell you that Base64 and SHA-1 are really awesome. So it's a place to start, and I'll just walk real briefly through what these fields mean. So we've started with a version number because clearly we will be extending this in the future to accommodate needs that will come up from hopefully your guys' feedback. The dots in there mean concatenation. And so there's a colon, and then this big thing underneath just means that we have a seed number, so that in different deployments you can make sure that these ID values, when they come out, differ, so you cannot confuse them. So you don't think that the setup over on the West Coast has the same hashes as the one on the East Coast, or whatever you're trying to achieve there. And then next to it is just the flow 5 tuple. There's a spec that I'll point you at in a second that sort of spells out in detail exactly how that stuff gets serialized, but it's basically what you would expect the flow tuple to be, so source and destination, IP and port, and the transport protocol. And this gets a little tricky for sort of the corner cases, like certain types of ICMP and so forth, but basically you can map these special cases into this sort of standard tuple. And then we just hash it. We basically picked SHA-1 because it's easy and available, and to compress it down a little bit so the strings aren't quite as long, we basically settled for Base64, which is sort of the simplest thing that's out there. And that is it. So, I mean, this is a super basic first way of going about this. And so what does this look like when you actually sort of run it? Well, here are the same log snippets that we had before, and you can see sort of, when you add it, then you basically get the exact same string in these different log types, and you can link them together. Awesome. So I don't know, how many of you would immediately find this very useful? I'm really curious. This is good. This is great, because we sort of solved that for us, and because people have probably sort of individually come up with solutions for this, but maybe we can we can use this from now on. So example use cases, clearly you guys seem to have things in mind, but so obviously the most obvious one that comes to mind is just you have different systems out there, they're all doing their data logging, and you want to link the data together. It can be like even more obvious in a way. For example, just where we came upon this was just running multiple Zeek clusters and still needing to correlate the data across those. So it doesn't even have to be different systems, sort of, but where you cannot necessarily rely on a particular system's native flow IDs being the same, then this gives you an insurance and an assurance that it's going to be the same value. An interesting one that came on our radar the other day via Vlad at ESNet, which is the US government's ISP, essentially, is that in really large-scale networks where it's not that easy to identify tapping locations, you are usually looking, or will often be looking at unidirectional traffic due to asymmetric routing. So you see one side of the connection, and they would like to have this so they can link those kinds of data together. So sort of, in a way, a special example of, the same system is actually running, but you still need to link data together. And then theoretically, we can take this beyond the Suricata and Zeek communities and get other tools to support this. Like you could see building functions into your SIEM so that you can, given a flow tuple, just come up with that calculation, because it's obviously not, particularly difficult to do if you have the sort of basic functionality available. So in theory, you could apply this in all kinds of settings, as long as everybody agrees that this way of going about it makes sense. So the current status, there is a specification where I'm sort of, I'm pausing because specification sort of suggests that this is very rigid and normative and so forth, and it's basically just a write-up of how this is supposed to work right now, and a Python reference implementation where there are some PCAPs, and you can run this Python script over them, and you see the hashes that get produced there, and you can basically see if, in an implementation that you might be coming up with, you get the same hashes or the same ID values, so you've done it right. Thanks to Victor pushing hard, this is in 4.1, which is super cool. So you can enable it today if you're running 4.1. And for Zeek, there is a package that is internally also a plugin, if you're familiar with this stuff, sort of, because we needed a little bit of binary functionality. But so basically, it's there today, and if you run either of these two systems, you can start using it right now. Since we're at Suricon, so if you're wondering how do you enable this, so you just go into suricata.yaml. The guys put everything you need right in there. You scroll down into the EV, do you say EVE or Eve? I actually don't know. Eve? Okay, cool. Log section, and you find description of what the community ID is about and how you configure it. You don't need to set the ID if you don't care. Just leave it at 0 and you're fine. And you just flip the main setting from false to true, and you're good to go. All right, so you guys seem pretty positive, but in past discussions, something else has also happened where people were like, but this is terrible, don't do it that way, okay? So I just wanted to caution again that this is super preliminary. So we've literally taken the simplest possible thing we could think of and used that. This is V1 because everything that we used is just there. We didn't have to add base64 to Zeek or to Suricata. We didn't have to add SHA-1 because it was already there. So the idea is that you guys can run this right now and try it out and let us know if it's what you need. And if it's not, then what do we need in order to improve it? A pretty obvious need for improvement is clear depending on the network type you're running this in and your hashing needs, your identification needs. So for a version 2, an idea that we've been sort of thinking about is adding configuration bits that basically tell you how a given ID is computed. And so an example that is sort of sketched out here would be that you might want to include VLAN tags or Q&Q or any of the other umpteen encapsulation techniques that are out there. You might want to use a different hashing algorithm because we might find that SHA-1 has problems, or you might not want to use any base encoding on top of it because you're perfectly happy with what the SHA hash looks like. And so this is just an idea at the moment, but at the bottom is an example of what this could look like. So basically like little strings that you prefix the whole thing with that don't really add a ton to the length and that tell you what configuration was in effect when you computed this thing. Very clearly, no matter what we use here, there is sort of a trade-off between runtime performance, how fast is this thing to compute, and collisions. And they may not literally be a trade-off, but both concerns come up, right? And it's not like we've studied this in depth. You can pull up umpteen articles on hashing function speeds, and there are lots of them out there. There's Murmur2, DJB2, and so forth. Again, the reasoning was simply that they were not in those systems by default. We can switch to them at a later time if it makes sense to use those instead. Like, no problem. That's sort of the stage we're at. Another biggie that people usually mention right away is time. Like, where was time in that function? And it wasn't there. So you could clearly say that this is weird. So if I hit the same flow tuple like a month from now, then that ID will look exactly the same. And our take on this so far was that by simply looking at the right sort of set of data, that will disambiguate things somewhat. But if somebody has a good idea for how to factor time into this thing, I mean, let's hear it. This is great. We just didn't want to do sort of the most obvious thing, which is basically like you take the current time where you're at and you round it to some granularity, and then you say like, well, just use that. Because no matter what granularity that is, you will at some point be very close to it, like very, very close. And if you have multiple systems doing the calculation at the same time, then for one, that threshold might already have passed, and for the other one, it's still there. And you would have a deviation, which is arguably worse than not having the same value in the first place. But there's plenty of cool stuff out there. If you have some idea for, I think this would be roughly the right name for it, sort of time approximate fuzzy hashing. I Googled that and I couldn't find a solution. Then by all means approach us and let us know. This is cool stuff. Other base encodings, so base 64 is okay. It doesn't necessarily look particularly pretty. There are characters in there that might complicate parsing at times. In Zeek for the ID, we're using base 62, just because that eliminates certain characters from the encoding. That makes it nicer to read. I didn't know this until recently, but in Bitcoin there's base 58, which basically also, I think, eliminates certain characters for risk of confusion, like I think I and J. And so in general, there is a trade-off here between sort of the length that you get, the readability, and perhaps also performance, depending on how costly it is to that encoding. And it's been interesting in talking to people how they immediately made certain, saw certain use cases and certain assumptions. I don't actually remember who the person was that first brought this up, but somebody immediately flagged, you're hashing this is great, so you can tell me that you've seen a certain flow without telling me what that flow was. So like basically two independent institutions could sort of check their data and identify that they've seen the same thing just looking at the IDs without needing to share, it involved IPX, IPY, that kind of thing. So that's sort of one extreme end, and the other is that this doesn't need to be a cryptographic hash function. At the end of the day, it's just an encoding, so you could literally just spell the whole thing out in one string. We could do that too. It seemed like this is maybe a little clunky, like the length will vary a lot and so forth. But I just wanted to flag that this is clearly a spectrum, and there are a ton of design points there. Like you can implement this in many ways, and again, the current thing was basically just sort of the most obvious thing that came to mind. I think lastly, I mean, if this becomes more popular, then we should probably think about building a library that just does this for you. Really obvious to see. You just put it out there in some decent set of languages, obviously C, maybe some Python, and so forth, so people can just use this without even depending on what is available in a given system right now. That could clearly simplify things a lot. And with that, I'm done. I know that I'm way ahead, but this is simply not that big a topic. So keep in mind, this thing is V1. It's usable right now. It would be awesome if you could try it and let us know what things you need in there for it to become useful, or why this is a really bad idea, or how we should move this forward. Send us feedback. You can create tickets on GitHub. You can chime in on either of the mailing lists. We'll be there. There is a reference implementation and spec that I pointed at, so go forth and let us know how well it works. And